I'm working on transmitting atomic clock signals. The problem is when you transmit an atomic clock signal, it gets degraded by disturbances on the transmission lines, and so you don't wind up with the full precision at your receiver. So I'm working on stabilizing that and restoring that precision.
I see. So even if the clock is accurate, where the actual person reading the time, if there's a little bit of delay or something like that, then it won't be accurate anymore?
Absolutely correct. So we want them to receive the correct time, and so we need to get rid of these disturbances.
And how are you doing that?
The basic systems all work pretty much the same. We bounce part of the signal back from the receiver and analyse it and compare it to the signal we transmitted originally. That way we can tell what's happened to it during transmission, and so we can pre-compensate the next outgoing signal to compensate for those disturbances on the line.
What kind of disturbances come along?
The disturbances usually come from things like vehicle vibrations and heating and cooling during the day, because mostly we transmit over fibre optic cables, like for the internet, so they run under roads and things like that. But also we can try transmitting up to satellites, and so we'll get atmospheric turbulence that'll disturb the signal.
And if you know what the turbulence is, then you can account for it with the original signal?
Yes, absolutely.
And why is this important? I'm always late for things, but it's usually not by a second, it's by about 20 minutes. So why is having really accurate time important?
Although we humans can only work to about an accuracy of a second, our technology needs much greater precision. So our GPS satellites are synchronized to nanoseconds, our financial systems are synchronized to microseconds. And so if we have better atomic clocks, we stand to reap huge benefits from better communications, better navigation, and science experiments that will help us unlock the laws of the universe. But to do that, we need to stabilize the clock transmissions.
And is there anyone else working on this? How close are you to sort of solving it?
There are groups working on this all over the world. The field of research itself is about 10 years old, and we're just getting to the stage where these systems are starting to be used in high-end science experiments like the Square Kilometre Array Telescope and the Atomic Clock Ensemble in space on the International Space Station. Give it another 10 years and you might be seeing these in commercial operations like mobile phone networks.